So in this lesson, we're going to be solving multi-step inequalities. The same thing as the same rule applies in our last inequalities lesson, where if you multiply or divide by a negative number on both sides, you must flip the inequality symbol. Now my tip is you're going to flip when there's a negative coefficient on the variables that are combined on the left side. So basically, once you get all your variables on the left side, if the coefficient is negative, you're going to end up flipping the inequality symbol. Okay. Now, there is one new thing that we're talking about today, and that's using interval notation. But I'm going to get to that in a second. Okay. First, I just want to talk about, we're going to be distributing and combining like terms and solving these inequalities just like our multi-step equations, except for this case, which is basically this rule. Okay. So actually, I'm going to do number 2 with you, because as a reminder, when you distribute, you always take the number in front of the parentheses along with its sign. Okay, so I'm going to copy the x because there's nothing to do with that, and we're going to distribute the negative 3. So it becomes negative 3x, and negative 3 times positive 2 is negative 6 greater than 4. So I'm going to combine the like terms that are on the same side, and 1x minus 3x is negative 2x. If you need, you can always write in that 1x in front, and then you have your minus 6 greater than 4. Now we just solve, and we have 2 steps. We're going to add the 6 to both sides, then we're going to divide by negative 2. And since all of our variables are on the left-hand side, I know that I'm going to end up flipping the inequality because I'm going to have to divide by a negative 2 on both sides. None of the other numbers make that decision except for the coefficient of the variables on the left side. Okay, so I'm going to add 6 to both sides. We've got negative 2x is greater than 10. Then I'm going to divide by negative 2, and as soon as I divide that negative 2, it's no longer true, and we have to flip it, and then I'm going to write it as x is less than negative 5, since 10 divided by negative 2 is negative 5. So this is the inequality answer. So when we graph it, we know, because it's a strictly less than, we're going to use an open boundary point. So anything that's strictly less than is the open point, or greater than, strictly greater than, you're going to use an open boundary point. And this is also from our previous lessons, and if there's an or equal to, that's where you use your solid boundary point on the graph. And with the variable on the left side, our inequality basically acts like an arrow. So if I have negative 5, I'm going to use an open boundary point because there's no or equal to, and I'm going to shade everything to the left, which tells me any number to the left of negative 5 will make this inequality true if I plug it in for x, for all the x's. Okay. Now the new part is the interval notation. Okay. Now, the difference with interval notation is we read from left to right, whereas with the inequality points which way we shade, okay? And what I mean by reading from left to right, I'm actually going to say you want to read the graph, okay? So, on the left side, we have this arrow. Well, the arrow continues to negative infinity, but it stops at this open bubble on 5, okay? So anytime you have the strictly less than or strictly greater than, you're going to use an open point. And when you have an open point, that's when you use a parentheses. And it could be either direction. So in this case, what's on the left side, it goes to negative infinity, and then it stops at -5, but we have this parentheses. Now, infinities, they're not like a stopping point. Infinity goes on forever and ever and ever. So we also have to use parentheses on a positive or a negative infinity. So we just say, okay, well, it's the interval, all the x's that are possible are on the interval from negative infinity to -5. And these parentheses on the infinity means it keeps going on forever. It's not like it stops. The parentheses on the -5 means there's an open circle on that boundary where it stops at -5. And basically, that also tells us x can get infinitely close to -5, but it will never actually equal -5, okay? All right, let's do, okay, sorry, I didn't realize I got a call and it interrupted my videoing, but at least I noticed that part of my notes on the side you couldn't see because of the view was too zoomed in. So again, just remember the rule: if you multiply or divide by negative on both sides, you must flip the inequality symbol. So my tip is, to flip when there's a negative coefficient on the variables that are combined on the left side. So once you get all the variables on the left side and there's a negative coefficient, you have to flip. Now, on the interval notation, just like we use an open point for less than or greater than, you use a parentheses anytime there's an open point. Or you can also think of it as you use parentheses whenever you use a less than or greater than. And it can go either direction, not just this way. It could be either this or it could be that way, okay? And you use the parentheses on a positive infinity or a negative infinity, which we'll talk about, and it's always from left to right on the graph, okay? You use a square bracket, and again, that square bracket can go both directions, and you only use it on a solid point, or if you have the or equal to on a less than or equal to or greater than or equal to. And we use the graph to help us with the interval notation, and we always read it from left to right. So I just want to show you. So number 4, I just solved this like you would a regular equation. The only difference is after I distribute, I get -8x plus 8 minus x less than or equal to -28. Combine the negative x and the -8x to get your -9x. You have your plus 8 less than or equal to -28. We want to eliminate the plus 8. So we subtract 8 on both sides. These eliminate. So you have your -9x. So I just want to show you. So number 4, I just solved this like you would a regular equation. The only difference is after I distribute, I get -8x plus 8 minus x less than or equal to -28. Combine the negative x and the -8x to get your -9x. You have your plus 8 less than or equal to -28. We want to eliminate the plus 8. So we subtract 8 on both sides. These eliminate. So you have your -9x is less than or equal to, and then the -28 and -8 are both add to -36. And this is where I meant right here. Now that we have all our variables on the left side, I know I'm going to end up flipping it in the last step because I'm dividing by a negative coefficient on both sides. So that's where when you divide by -9, the inequality is no longer true, and you get x is greater than or equal to +4, since -36 divided by -9 is positive. So we know we graph this with a solid point on 4 because of the or equal to, and you shade to the left because it's pointing to the left. So when we do the interval notation, we go from whatever we hit first on the graph from left to right. Up here we hit the negative infinity because it was the arrow, we hit the arrow going to the left. But here we hit the 4 first, and since it's a solid point, we use a square bracket. And then on the left side is the positive infinity, and we use the parentheses because the infinities never end. Now, on this side, and let me just check to make sure it's in the view. Okay, I just want to make a note. These are the answer keys, but I'm looking for all the work, because the work gives you full credit, and your graph that should match the interval notation, okay? So I wanted to look at 5, 6, or 5, 7, and 9 on this side. Now, just like equations with variables on both sides, we want to eliminate the variables on the right so we can get all our variables on the left, and that tells us if we have a positive coefficient, we're not going to flip. Okay, so once we solve, we get x is less than 1, so we have an open point on 1, and it's shaded to the left. Okay, then we switch gears and go to interval notation, and we no longer look at the inequality, we look at the graph. So if you notice, I'm using my finger from the left side. The first thing I hit is that arrow. So that tells me I put, since it's the arrow to the left, it's negative infinity. And then it ends on the right with this open point at 1. So we put 1 with the parentheses because it's an open point. And we know we always put parentheses on infinities, whether it's positive or negative infinity. And then down on number 7, I just wanted to review, we don't do anything with that 3 yet because we have to distribute that negative 1 into the parentheses first. Then we can combine the 3 and the 7 to get your 10, and we still have on the other side 34 minus 6x. So I eliminated on the right side by adding 6x, combined with the negative 2x is your 4x. Now we have our 10. And right away I can tell before I even do the subtracting that I'm not going to flip because it's a positive coefficient. So I subtract the 10x on both sides. I get my 4x is less than or equal to 24 divided by 4. That's where I get my x is less than or equal to 6. So we know we use a solid point on 6, and since it's pointing to the left, we shade to the left. Okay, so that's our graph. Now to read our graph, to do the interval notation, well, on the left, the first thing I hit, because we always read from left to right, is this arrow which goes to negative infinity. So that's the first thing I write, because negative infinity is the furthest on the left. And then the furthest on the right is positive 6. And we use the square bracket because it's a solid point. And we know we use the open parentheses or on the negative infinity. Now this is not a coordinate. These are, we say it's the interval from negative infinity to positive 6. The closed interval on 6 is any solution for x. Okay. Similar on number 9, the only difference is just reviewing that we can't do anything with the 5x yet, but we can distribute the negative 3, and then we distribute this negative 1. We can't do anything with the 8. Then we combine like terms. So that's where we get our 5x, and then we have a negative 3x, and then negative 3 times 6 is minus 18. Copy the 8, negative 1 times x, negative 1x. Negative 1 times negative 7 is positive 7. We combine the x's to get positive 2x minus 18 greater than or equal to, we do our x's first, negative 1x, and then positive 8 and positive 7 is positive 15. Then we eliminate the minus 1x, so we add the 1x to both sides. Then we eliminate the negative 18, add the 18. So we get 3x is greater than or equal to 33, divided by 3. That's where we get the x is greater than or equal to 11. So we know we put a solid point on the 11 on the graph, and we shade to the right. That's our graph. But our interval notation, this time, from the right, we don't hit an arrow. We hit the solid point, which is at 11. So we use the square brackets are for solid points and or equal to signs. And then on the furthest to the right is our positive infinity. So we put our parentheses because that tells us the infinity goes on forever. So go ahead and do numbers 10, 8, and 6, and numbers 1 and 3. And remember the work is what I'm looking for to get full credit, along with the graph that matches the interval notation. Now, you need to be able to use what you got from your answer and your graph to write your interval notation. Remember, you read your graph from left to right, which is different than how you use the inequality, because the inequality, you put the boundary number and then the inequality acts as an arrow telling you which way to shade. So bring questions to class and we can clarify anything that's not clear